Before diving into the full story of mining's environmental transformation, here's the essence. Mining companies worldwide are pioneering remarkable innovations to slash their carbon footprints, from massive solar farms powering remote gold mines to electric megatrucks that generate energy going downhill. While the industry still contributes 7 to 8% of global emissions, these breakthroughs show a cleaner future is possible if companies accelerate investment in renewable energy and revolutionary technologies. The hidden environmental cost of modern mining is huge. Every smartphone in your pocket, every car you drive, and every building you enter shares a common origin story. They all begin in a mine. The metals that form the backbone of our modern world start their journey deep underground, extracted through processes largely unchanged for generations. Picture this. Massive haul trucks rumble across vast open-pit mines, their diesel engines belching exhaust into the air. Explosive blasts shake the earth, dislodging enormous chunks of rock. Energy-hungry mills crush and grind that rock, consuming staggering amounts of power, largely derived from fossil fuels. The environmental toll is immense. Mining and metals processing account for a shocking 44% of all industrial carbon emissions. The mining industry alone consumes about 4% of global energy just for grinding ore into usable material. When that ore becomes steel, the carbon footprint grows even larger, producing approximately 1.85 tons of CO₂ for every ton of steel manufactured. The fundamental chemistry of this industry hasn't changed in 2,000 years, explains Christina Chang, a former Department of Energy official who now partners with lower carbon capital. Mining's carbon-intensive processes have persisted not because of indifference, but because alternatives have been scarce, until now. For solar revolutions, mining materials like silica is a must. In the remote deserts of West Mali, near the Senegal border, something remarkable is happening at B2Gold's Fekola gold mine. Far from any electrical grid, this operation would traditionally rely entirely on diesel generators burning heavy fuel oil around the clock. Instead, a massive solar array coupled with a 15.4 megawatt battery system now provides up to 75% of the mine's electricity. The transformation extends beyond Africa. In Western Australia, Goldfields' Agnew mine broke records by becoming the first major mining operation worldwide to combine solar, wind, battery storage, and backup gas generators. This hybrid system now supplies the mine with reliable 24/7 power averaging 54% renewable energy. The economics are as compelling as the environmental benefits. At Zimbabwe's Venice gold mine, a solar diesel hybrid system is saving approximately 75% on electricity costs compared to diesel alone. In Australia, the DeGrussa mine's solar installation displaces an impressive 5 million liters of diesel consumption annually. For the energy-intensive mining sector, selecting high-quality technology partners is paramount, notes Neil Canby, Managing Director of Sunrise Energy Group, who helped implement such systems. These successful implementations prove renewable energy can reliably power even the most remote and demanding mining operations. Imagine a vehicle so massive it could crush a family car without noticing. That's a typical mining haul truck. These behemoths traditionally consume enormous quantities of diesel, but that paradigm is shifting dramatically. In a groundbreaking innovation, Kuhn Schweiz converted a 111-ton Komatsu mining truck to electric operation with a massive 600 kWh battery pack, the largest battery system installed in any vehicle to date. What makes this truck truly revolutionary is that it doesn't need external charging. As it carries 60 tons of limestone downhill, the regenerative braking system captures enough energy to not only power its uphill return journey, but also feeds surplus electricity back into the grid. The economic case for electrification is compelling. According to IDTechX research, mining companies can save nearly $2.5 million per haul truck electrified, with trucks breaking even on their added capital expenditure in under 2 years. Major mining equipment manufacturers Caterpillar and Komatsu are racing to commercialize electric haul trucks, with production models expected before 2030. Rethinking rock breaking, the energy revolution. One of mining's most energy-intensive processes happens after extraction, breaking down rocks to access valuable minerals. This step, called comminution, consumes up to 53% of a mine's total energy, but astonishingly, 95% of that energy is wasted as heat, noise, and mechanical losses. Innovative companies are tackling this inefficiency. Canadian firm Rockburst has developed a revolutionary CO₂ pulverization technology that breaks rock using carbon dioxide rather than traditional crushing methods. Our technology uses CO₂ to promote tension within the ore, not compression, meaning we break the rock using considerably lower energy, explains Rockburst CEO Oscar Malpica. The company aims to reduce energy consumption by up to 50% while eliminating water usage entirely. Another approach focuses on smarter blasting. Studies show that optimizing explosives used in the initial mining stage can dramatically reduce downstream energy needs. Blasting is the most cost-efficient means for ore size reduction. Chemical energy is cheap compared to electrical energy, notes a Mezzo report. Mining operations implementing these techniques have increased throughput by 5 to 20% while reducing energy consumption. From brownfield to greenfield mining sites' second life. What happens when a mine reaches the end of its productive life? Increasingly, the answer is surprisingly green. Across America and beyond, former mining sites are finding new purpose as renewable energy generation centers. In Maryland, a retired coal mine in Garrett County is being transformed into the state's largest solar farm. The site's existing grid connections and substations, once obstacles for new solar projects, are now valuable assets. The U.S. Environmental Protection Agency estimates there are over 450,000 brownfields nationwide with similar clean energy potential. We should seize every opportunity to give legacy dirty energy sites new life harnessing renewable energy, urges Johanna Neumann, Senior Director of the Campaign for 100% Renewable Energy at Environment Maryland Research and Policy Center. These projects offer dual benefits, cleaning up environmental liabilities while generating clean power. Steel's Carbon Challenge, Reinventing a 2,000-year-old process. Steel production represents mining's largest carbon challenge, contributing nearly 8% of global CO₂ emissions, more than the entire European Union. Traditional steelmaking requires heating iron ore, limestone, and coke, a coal product, to extremely high temperatures, releasing massive amounts of carbon dioxide. The carbon footprint varies dramatically depending on the production method. Traditional blast furnaces emit around 1.987 tons of CO₂ per ton of steel, while electric arc furnaces using recycled steel produce only 0.357 tons, saving up to 1.787 tons of CO₂ per ton. The U.S. Department of Energy has recognized this challenge, announcing $1.5 billion in grants for low-carbon ironmaking, and another $28 million for cutting-edge approaches. Innovative companies are developing processes that use renewable electricity instead of carbon-containing chemicals to extract metals from minerals, potentially slashing emissions. In Path Forward, there is a need for an accelerating green transformation of mining. Despite promising innovations, the mining and metals industry is not yet on track to achieve net zero emissions. The transformation requires comprehensive change across several fronts. First, electrification must extend beyond showcase projects to become standard practice. This means redesigning heavy equipment to run on electric power and establishing renewable energy infrastructure at mining sites worldwide. Second, process innovations like carbon dioxide pulverization and optimized blasting need rapid commercialization and widespread adoption. These technologies not only reduce emissions but often improve productivity and lower costs. Third, the steel industry requires fundamental reinvention. Shifting from traditional blast furnaces to electric arc furnaces and developing new chemical processes that don't rely on carbon can dramatically reduce this sector's emissions. Finally, policy support and investment are crucial. Government incentives like the U.S. Inflation Reduction Act, which provides a tax credit of up to 10% for clean energy projects built in former mining communities, can accelerate adoption of these technologies. Conclusion: mining's sustainable future. The mining and metals industry stands at a crossroads. The path forward requires embracing innovation across every aspect of operations, from extraction to processing to transportation. The examples highlighted throughout this narrative prove that change is not only possible, but economically advantageous. By investing in renewable energy, electrifying equipment, optimizing processes, and developing new technologies, mining companies can significantly reduce their carbon footprints while improving efficiency and profitability. As we transition to a low-carbon future, the demand for metals will only increase. Electric vehicles require 6 times more minerals than conventional cars, and wind farms 9 times more than gas-fired power plants. Meeting this demand while reducing emissions represents mining's greatest challenge and its greatest opportunity. The revolution has begun, but time is short. Our global climate goals depend on mining companies accelerating their green transformation, not tomorrow, but today. As you come so far, don't forget to like, comment, and share.